Okay, so today I'm not going to be writing much. I'm just going to be talking about min-max derivative problems and kind of the process to go on how to solve one. So usually when you have these problems, you're going to have two equations. And so what the goal is going to be is to get a single variable equation. And then once you get the single variable equation, there's stuff we're going to do. But when you have the two equations, you're going to isolate one of the variables, either x or y. And then you can substitute the x or y into the second equation. And when you do that, then you will have a single variable equation. And then from this, my pen just ran out of ink. When you get to the single variable equation, then what you're going to want to do is take the derivative and then once we have the derivative, we're going to set it equal to 0. And then once we set it equal to 0, we will get our, find your critical number. And this critical number, if we think about the derivative and what's happening, if the derivative looks like this, okay, if the graph looks like this, when we set the derivative equal to 0, we will have a point at which the slope of the line changes from decreasing to increasing, or from increasing to decreasing, or vice versa. So what we're looking for in the min or max is a point at which, okay, it reaches a min, or if it's the opposite, if it's a minimum, it'll be at the bottom. But where that slope levels off, and where that slope levels off is going to be a point of either a maximum or a minimum value related to the extreme of things. And so that's what we do when we solve for min-max equations. Kind of a process of getting the two equations, putting it into a single variable, taking the derivative, and then setting it equal to 0. Kind of that process. Sorry that sounds confusing. I hope that was helpful.